in this problem we have a test charge located away from some unknown source. And we know the amount of field we have. We're given the field strength in newtons per coulomb. So we have some source, let's call it A. And over here we have some test charge, positive Q. And what we do know, it's being attracted. So I have a field strength that's to the left, E, which we actually know. E is 85,000 newtons per coulomb. And what I don't know is what is the charge of this source, charge of A. That's what I don't know. And so I have E. I'm looking for a charge. I also know a distance. 50 centimeters is 0.5 meters from here to here, so I have a distance. And so hopefully you recognize that I could take this equation, E equals KQ over D squared, and we're going to solve for Q, or Q of the source, or QA would probably be better. It doesn't really matter how you label Q. All right, and so if I solve for Q, then I'm going to get the charge of my source, charge A, is going to be equal. I'd multiply both sides by D squared. That cancels that out. And then I would have to divide by K on both sides. And I would be left with an equation for it equal to E times the distance squared over K. And I can plug in my values. So I have 85,000 that's given for the field strength in newtons per coulomb. The distance is a half a meter, and I have to make sure I square that. Now divide by K, which is 9 times 10 to the 9. So let's see what we get in our calculator here. 85,000 times 0.5 squared divided by, I have K stored as alpha K, and I get 2.36 times 10 to the negative 6. 2.36 times 10 to the negative 6 coulombs. Now, 10 to the negative 6 is micro. So I can say it's 2.36 microcoulombs of charge. Now, we also need to have something else. Is it a positive source or a negative source? Well, if a test charge is being attracted, then A must be a negative source. All right, so our answer has to have the negative, and that's because it's being attracted. The positive test charge is attracted, which tells you it must be a negative source. So that was one piece. Make sure you don't forget about the sign. If they want the charge, you need to indicate whether it's positive or negative. Unless they just say what's the magnitude, in which case it would just be 2.36 microcoulombs. If you left it as 10 to the negative 6, that would also be correct, because it doesn't change the actual value.